Uh, so my name is Kunle. I'm a web developer in Ann Arbor, and I just wanted to talk a little bit about HTTP2, which is a new version of HTTP that's been rolled out by the people that roll it out, and it's come out since last year, and it's been kind of rolling out and getting more popular, and it has a lot of new features that are pretty useful. So basically, to start off, what is HTTP? We all use it every day. We probably already know what it is, but it's a protocol that resides at the top of the stack, of the OSI stack model. So basically, when you send data from one device to another, the data is basically encapsulated in all these different frames that kind of describe what the data is and where the data is going. And that's pretty much what HTTP is. It pretty much describes and helps give meaning to the data by adding metadata to it. So basically, you get like all these different layers that add data, like session layer, transport layer, network layer, it keeps going, data link layer, physical layer. It's almost like a burger, all the layers that you have. And HTTP kind of resides at the very top of the layer, in the application layer, because the application is what adds the HTTP frame to the actual data. So moving on. If you've seen like an HTTP packet, it kind of looks like this. You get like a request, a GET request, a POST, an update. And the first line is a request line. And you basically are requesting some kind of file or some kind of web page. And it could be like just visiting a web page or just like getting an image or some kind of thing like that. And you tell the server, okay, I want to get this resource, and I want to use this protocol, HTTP. The most popular one being 1.1, which is what's being used for the most part right now. It's pretty verbose. There's a lot of text. There's a lot of white space. It's really easy to read as a human being, but as a computer, it's a little bit hectic to kind of parse through it. And when you send that to the server sends you kind of a response. If you've seen a response, it looks like tells you the protocol. It tells you if it's a 200 or 404, if it's an error. Tells you what kind of server it was. And that's pretty much what the status quo is for an HTTP request and a response. But it's kind of old. It came out in 1999, and that's almost when I was born, so it's pretty long. So it's the most widely used version of HTTP, which is 1.1. It was designed with ease of adoption in mind. So it was at the beginning of like the internet when it was becoming really popular. They wanted this protocol to become like the de facto protocol that was used, and they got it right because it did become the de facto protocol. But it wasn't optimized for like today's really content-rich applications or websites that we have. So we have like websites with tons and tons of images and tons of communication transferring back between the client, the browser, and the server on the company side. And there's just a lot of overhead that's involved with all these communications and all this metadata that's in the header of all this data that you're sending back and forth. So as developers, you may have made this smirk before. Basically, you have to go through a whole bunch of crafty ways to kind of get over the limitations of HTTP1, or 1.1, which one of them is domain sharding, which basically you split up your domain so you can host different assets on different domains, because the browser actually limits how many TCP connections you can have open at once. So you can only download so many files at one time based on how many connections you have. So people have found ways to get around that using domain sharding while making that face. And then also you can use sprites, which basically you combine your images on your web page and you put them inside one big image. And then kind of when you want to access them, you just access that specific location in that big image. So you're not downloading multiple images every time you want to load a page. So that's another way to save overhead by reducing the amount of requests that you make. There's data inlining by just including your data inside like your page, which is terrible. Please don't do it. It sucks. And then there's also concatenation, which is like concatenating your CSS files so you just have one big file instead of a bunch of mini ones. So basically, there's a bunch of ways to kind of get around the limitations of HTTP, but that's not the way we want to code. We don't want to code to get around the limitations of something. We just want to make that thing better, which is basically their idea behind creating HTTP2 and just making it better. This is what domain sharding looks like if you were curious. The server, you have different domains, and all go to one web page. So then comes HTTP2 to come and save the day. It was actually started as an experiment by Google. It was originally called SPDY, which kind of stood for speedy. Basically, there was two really, really smart PhD engineers at Google that decided, hey, why don't we just make the internet 50% faster? Which, that's awesome. I mean, if you're paid a ton of money, I mean, that's definitely the thing to do. So they actually created like a project, they called it SPDY. They experimented with different methods and different protocols to kind of speed up the traffic between client and browser to see if they could increase the flow of traffic and kind of decrease overhead. They tried to reduce site latency, so they wanted to make it so when you load a page, it loads as quick as possible without having to send too much metadata if it's not needed. So they kind of experimented with that for years, and it was actually a big project. They open sourced it, and it got insanely popular. It came out in 2009, and over time, Twitter eventually picked it up immediately. Facebook picked it up immediately. They used it. They used a lot of the methods that were defined inside of that protocol. So they were trying to optimize it, and they actually succeeded. So basically, the methods that are kind of used in HTTP2, which is basically SPDY is HTTP2 now. It pretty much adopted that. But the first one is multiplexing, which is like you basically get to split your packets into frames now. Normally, you'd send a single HTTP packet along one connection, and then you'd wait for that to come back, and it would take forever, and then it would send another one. But now, they use these things called streams, where you can use one connection and send multiple HTTP frames along it. So you can send pieces of each packet interleaved between each other, kind of maximizing the performance of using a single stream without having to create a bunch of new ones. So that was a huge thing. It increases like performance incredibly. And then it allows you to send more than one request and response per stream, or per connection, I'm sorry. And that basically reduces the amount of overhead you have to create every time you create a TCP connection. Because normally you'd have to create a new connection every time you wanted to get a file, or every time you wanted to send a request, you'd have to establish a connection between the server. Now you only have to do that once. And that basically allows you to eliminate that overhead, and kind of eliminates really the need of domain sharding, concatenation, image sprites. You really don't have to do it. So this is kind of what it looks like if you were at like McDonald's. Instead of having like 3 servers all just coming like, hey, do you want a burger? I'll give you a burger. Then another guy coming, hey, do you want a drink? I'll give you a drink. You can just have one server, or one waitress, whatever you want to call it, that will give you everything that you need at once, instead of having to open different connections, different relationships. So it kind of optimizes in that sense as well. And if you want to look at it from a more technical standpoint, those different lines are streams. So as you can see, they're sending the headers and the data as different frames, and there's sending the frames inside of one stream for different files. So in the first stream, it's like you're sending the first frame of the first file, then the second frame of the second file, then the second frame of the second file again. Is that the second frame? No, it's the second frame of the first file. No, it's the second frame of the... You know, it's actually a very confusing image, and I don't think I should have used that one, but it makes sense, I swear. But basically, it's interleaving the different packet frames so that it kind of optimizes each connection. So the next thing that is used in HTTP2 to, okay, here we go, all over again. So the next thing that's used in HTTP2 is something called server push, which is also an incredible finding that they found, was that instead of waiting for the client to request a file, you already know which files they're going to ask for beforehand most of the time. So if you know that they're going to visit your site, they're going to request the CSS file, they're going to request this main image, they're going to request these content blocks, you can send those files before they even have to send the request. So that actually saves the overhead of actually sending the request from the client and reduces latency on the web page. So this kind of makes a huge deal because this can actually be used for subsequent websites as well. You can actually cache these pushed resources and save them inside the browser. So if you go to, let's say, 9gag.com, and you wanted to visit like a joke or something like that, and you want to go to maybe like the comment section, the next page, the server can actually push you that information before you even go to the next page in anticipation that you're going to go to that next page. So you can save that data without having to request it. So when you go to that page first, the page loads faster, and you don't have to send as much resources on the wire, so you're saving bandwidth. So this actually caused a huge increase in page load speed and also reduced bandwidth usage and just made everything way, way, way faster. So this image kind of explains it a little bit. You're loading a page, you request HTML, but the server sends you everything for the site from that one request. So you only requested the HTML, but it sent you the CSS, all the images, because it knows you're going to ask for it eventually. So basically reduces the amount of requests that you have to make as a client.
Because you're sending much more data than you anticipated.
What was that?
Sorry, is it still faster because you're sending much more data than you expected?
It is, for the most part, it is faster if you're like loading images that you would load regardless. But you can, as a client, like actually stop the push if it's too much. So for the most part, it is faster. They found that like if you can actually accurately predict which files that the client is actually going to request, then it makes a huge difference in terms of not having to send the request, not having to establish the connection, which oftentimes is like you send the I'm contacting the server, talking to them, acknowledge my existence, and then we send the file. You know, it kind of reduces all of that overhead of communication between the client and the server. So yeah, it increased performance a lot, that as well. That was one of the more novel concepts behind it that was adopted really quickly.
I understand it correctly that then what it could also do though is to push content out to a proxy or a caching proxy so that it was already cached at the proxy level.
Yeah, yeah.
Part of the
You mean like pushing it to like a proxy server?
Yeah,
so
it knows that the client's are going to ask for it, it can actually push it into a cache. Not the client's
yeah.
cache, but an intermediate cache.
Yeah, exactly.
And then when the client came, they wouldn't be bothered with the request.
Yeah, I think that's exactly right. In fact,
things that happens right now with different topologies where people are pushing out the engine next, for example, which supports HTTP2. The server that doesn't support it can push things out to those edge nodes, and they will be able to cache and reduce their communication back to the server. So yes, proxy servers are supposed to do that.
So that's cool. And then the next thing that it does is they also added this like protocol where you can actually, or what's supposed to happen is you can convert your commands in HTTP to binary. So right now it's actually being sent as plain text from the HTTP layer, and it's really easy to read like via some kind of packet sniffer, like with Wireshark. You can look at it and understand it, but it's actually really slow to parse on the computer's end. So converting it to binary actually reduces the size of it and reduces the footprint, makes it faster, and it's also just faster to read on the server's end. So you can actually parse through these HTTP commands really quickly if they're in binary. So it increases the throughput, reduces errors because HTTP commands are pretty terrible because they can have like optional white space and just a lot of optional characters that just make it really difficult to parse on the computer's end, which definitely just adds to more time to the latency. So basically like an image is, I need HTML, you convert all of that to binary, it goes to the server, it can read it really, really, really quickly. So that's another thing. And then the last thing is header compression, which kind of goes hand in hand with the binary conversion. Basically, it compresses the headers of each packet, HTTP packet, into like a kind of a minified version. It's kind of interesting because, like I said before, they kind of maintain a single TCP connection when they can, so that they can send all of their traffic on that single connection, whereas currently in HTTP1, each new file typically has to create a different TCP connection. So now that you have a single connection that's kind of remembering all the files that it's sending, you can kind of create like this algorithm which they call HPAC, which kind of just understands which pieces of the header are the same for each packet that's being sent. So it kind of creates a dynamic table that basically saves the header pieces that are already known to be in each packet and just converts them into just single numbers. So that actually increases efficiency huge. Increases efficiency. That increases efficiency. It makes it really fast, basically. It makes it very fast. It makes it a lot faster.
Like the subheader, the big long string is just encoded as a byte or something?
Yeah, well, I don't think it's the entire accept header, but like the actual option, if it's used like frequently with other packets, then they'll just convert it to a number and save it inside the client's like little, it's almost like a cache. So it doesn't have to send the entire text string, it just has to send that number, which the client knows what it means. So it's almost like remembering, it's like just optimizing it, which it makes a lot of sense because you're sending like packets that are coming from the same origin, the same like website, and they all have like the same headers, the same information. You don't need to send them back and forth over and over again if you already know what they are. So it's just another way to kind of reduce the amount of data you're sending back and not repeating what you're sending back and forth, just to make everything a little bit faster. So like I said, it creates like a table, it saves data that's basically known to be the same for each connection, and it encodes that inside of the header, so it actually is just really, really small. There's an image, it's kind of simple, but it just goes through this algorithm, gets shrunk, and then gets sent to the actual server. So in conclusion, HTTP2 provides numerous improvements. You don't really have to do anything as an application or as a developer to really allow your application to use it. It's mostly on the server side or on like the low-level network layer. So if you have a website or a web application, it's most likely HTTP2 compatible. You just have to allow your server. Most times it's just a click of a switch. Like Akamai supports it, Cloudflare supports it. It's not very hard to implement, and it has huge benefits in terms of making your site just faster and use less bandwidth. And then there was just one more thing I wanted to show, which Cloudflare actually has a thing on their website where they can show you how much faster HTTP2 is versus HTTP 1.1. You can reload this. It's loading 200 images. That's with HTTP 1. With HTTP 2, it's about 1.5 times faster, just by using those few methods. So you don't really have to change any of your code, just have to turn it on the server most times. And you just saved that much bandwidth and latency on your website. So that's it.